Hi everyone, this is a summary of Chapter 3, Analytical Epidemiology in Community and Public Health. I'm going to mostly just do an overview of Chapter 3, so I don't have every single slide in here, so it's important to make sure you read the chapter, look at the slides again, and use the book to further understand. But hopefully I can give you a good overview as I do the voiceover. Part of this is understanding the different types of epidemiological studies. They're also common designs that we use in health promotion and other type of health behavior research and studies. This first one is observational studies. Usually I like to think about, when you're just observing and looking to see what are participants doing? What are people doing? But when we think about purposeful research observational studies, there are two different types. The first one is a case control study. So here you're looking at two different individuals. One has a specific health condition and the other one does not. So you're looking to see, what is the difference? What are some risk factors? Or possible exposures that might help explain the difference. And that's a type of retrospective study. The other type of study is cohort studies. So this is when you are, when you're looking at a group of individuals who share a specific risk or exposure, and you're observing them or following over time. And so you may look to see, is something going to develop? And typically these cohort studies are fairly large, especially to account for when you're trying to understand, is something going to develop? That really occurs in oftentimes small percentages. And so you really have to have a lot of people when it comes to cohort studies. So again, just thinking about case studies, those are retrospective because you're kind of looking back in time, and cohort studies, you're following people and looking from the point of time that you start forward. So those are prospective studies. The other type of studies are intervention studies or experimental. So whereas the first observational studies, there was no intervening in the way of trying to manipulate either their behavior or some type of condition they're exposed to. It's really just observing, seeing what happens, whether retrospectively in a cohort study or prospectively in a cohort study. Retrospective case study, prospective cohort study. So whether you're looking back in time or forward in time. Now, intervention studies are different because here you do manipulate a variable. So it's easy to think of classic examples in medicine. One group of people get the drug, the other group gets a placebo. In health behavior research, that tends to be a specific program or intervention or something that's being manipulated to see how that affects either behavior or a health condition it may have. So those are intervention or experimental studies. And again, the difference is that you're manipulating something and seeing how that affects the participant. Now there are a few different types of intervention studies. The first one you might hear a lot. Usually people shorten it to RCT, and that stands for randomized clinical trial. So here, again, you have two different groups of individuals. One is the experimental group. The other is the control group. Ideally, participants don't know which group they are. So again, when we are talking about medicine, which is always easy to think about, one group gets a drug, the other one gets the same pill, looks the same, but it's a placebo, so there's actually no effect, and you randomize. So you can blind the participants, which is often done. You can blind both the people doing the measurement and the participants. Or you can also blind everybody so that only the statistician knows, who actually got the experiment. Now, it's a little bit more tricky in our area of health promotion and doing research on behavior, because some of these interventions, you can't really hide who's getting what. So, for example, the church randomized control trial or clinical trial that I was a part of, the experimental group got a physical activity intervention, and the control group got cancer-related workshops. So in our field, sometimes it's not possible to blind, but they don't always have to know which one is the experimental group. It could really just be that there's almost like two mini interventions going on. But again, there's a randomized control trial. There is some randomizing happening, so participants are assigned to one group or the other. So that's what makes it, the gold standard. You have a group of 100 people. Every single person has an equal chance of either being in the experimental group or the control group. It's really like a flip of the coin. So that's randomized clinical trial. Sometimes, as I said earlier, you might even hear randomized control trial, but generally people shorten it to RCT, and so you'll hear that a lot as well. What we talked about earlier, that type of RCT is usually from the individual. Now, when you randomize communities as a whole, or even groups as a whole, like schools or entire communities, like a city, those are called randomized community trials. And sometimes if it's a smaller group, people will say randomized group trial. So this is where the factor under study is manipulated and is given to an entire community, so usually 2 or more. And again, because it's a randomized community trial, there's an equal chance. It's like a flip of the coin. If there's 2 or more communities, they have an equal chance of either being in the experimental condition or the control condition. When we talk about quasi-experimental studies, now when we think about quasi, the main difference is that it is not, there's no randomization. So while there is manipulation of a variable, which is the experimental side of it, there is no randomization into either an experimental or control condition. And there could be a variety of reasons. It might have to do with ethics, it might have to do with practicality. I guess one example could be if you wanted to study schools and there was a particular school that was willing to be the experimental group. Perhaps there's some reason, and in that case, if you are not going to give the 2 schools a chance of equally being in the experimental or control, now you've turned it into a quasi-experimental design. And things can happen like selection bias. Maybe that school was particularly excited. Maybe that influences the results in a certain way. So that's kind of the limitation to quasi. And again, sometimes it's convenient, sometimes ethics are involved, where you might not be able to say, okay, we want a certain group of people to, have a particular risk factor, or there's a lot of ethics and a lot of reasons, and we'll actually talk more about it in our research methods class. But the thing to note here is quasi-experimental studies have no random assignment to the different condition. So that's the main difference. A bit deeper into case control studies, you have 2 groups of people. So again, case control is retrospective, so you're going back in time. Now the 2 groups of people, you have one group that are the cases. So these are those who have a particular health condition that you're interested in studying. And then you have controls. So those are usually a group of healthy individuals, or at the very least, those without the health condition that you are studying. By looking at both those who have the health condition and those without it, you'll be able to look back in time and ask about exposure and other factors that might relate to whether they have or do not have the health condition. When you down into the type of steps that you would need, first you need to select the cases. So coming up with really good inclusion and exclusion criteria, you need to be very specific. What is it that you're studying, and why are these the cases? What is it that they have? Is it a health condition? And then for the controls, it can be, general population or subgroup. But generally, you are very purposeful. It's not just anyone that you're getting as controls, because the next step is matching, and you want to make sure that at least you have the ability to match. So matching is, aside from the health condition of interest, you want to match as much as possible around age, sex, race, ethnicity, and any other variable that you think is important. If you can match, to the best of your ability with only the health condition being different, we know that could never be 100%. Everybody is an individual and has their own experiences, and there's, we are just so complex. But the more that you can match, the more confident at least you can start to be in understanding, what some exposures are that might have led to the health condition by comparing to controls. So after you do the matching, the next thing you do is measure the factor under study. So whether it's a questionnaire, you're doing an interview, looking at medical records, now you're trying to understand, here are those who have a health condition and those who do not. What is the difference? What were those who have the health condition? What were they exposed to? And is there any difference from those who are healthy? Looking at it. So the columns up and down are your cases and controls. So yes, the cases have a health condition. No, the controls do not. And then the rows are yes or no based on looking at exposure or any other factor that you're interested in understanding. What it does is set up a really nice 2x2 table if you're just looking at A, B, C, D. And you've probably had this if you're taking biostats. It's a nice way to do a chi-square analysis. So this is one way of being able to understand among those who do have a health condition, what percent of those have this particular exposure, and compare that to those who are healthy or the controls. What percentage of them have this particular risk factor or exposure. And it begins to paint a picture of any influence. And again, this is retrospective, so you have to consider a variety of things. But statistically, you can do some things like chi-square analysis to understand, is there a difference in the study factor or exposure or a risk, some type of risk that led to the cases having this health condition. Now again, when you look at cohort studies, it's following a group of individuals that has some type of common characteristic, even a specific time period, like maybe following millennials. But other examples are, a birth cohort, age, maybe some type of similar exposure, or maybe the timing of when you joined an MPH class. So you hear us say a lot, you guys are the first cohort. And yes, that means we will be following you guys as you progress, obviously through the MPH program, but we hope to keep in touch with you and follow up and learn about, what jobs do you get, where do you end up? So this is our own, program, cohort study, and you guys are our very first cohort. So that's, and again, cohort is prospective. So starting from now, we will be looking into the future as time goes, versus looking back in time. So you guys are a great example of what a cohort is and how that's different. What's different here is that you can look to see, what risk behaviors or health outcomes develop, and then you have those who don't develop it. So now you can start to look again at a study factor. Were there certain exposures? Were there risk factors? What was it that may have influenced the development or avoidance of developing a certain health outcome? And again, it sets up this really nice 2x2 if you're looking, ABCD. And again, you could do like a chi-square analysis to really understand, is there some influence, is there some statistical meaning into the differences between those who developed a specific outcome and those who did not, based on specific factors or exposures. So again, cohort study, looking forward in time, which is the difference between case looking back in time. So again, that's kind of what I've been talking about for number one. You can have a retrospective cohort study. It's a little bit harder to do. You would have to have the data to do that. So that's a second type of cohort study. So cohort, usually we talk about prospective studies, and that's what I've been mentioning, but there is indeed a cohort study. And again, the difference with case control is you have, healthy cases and those with a condition and those without a condition. Cohort study in the retrospective way goes back in time, and you're still looking at groups. And again, just to get a little bit more into randomized clinical trials, what defines it is that there's some type of manipulation, whether it's an intervention or a program or some type of exposure. The second thing is that there are two, I'll add, or more groups, so two or more groups. And then mostly you want to make sure that participants are blinded to the study, so they don't know whether they are in the experimental or control group. Now the study factor, the thing that's being manipulated in medicine, is often a drug, but it can also be a preventive agent like a vaccine, and in our case, some type of community or public health intervention like an education program, screening. In my work, I do physical activity programs. And another one could be, surgery or some other type of medical procedure. So again, with randomized clinical trials, there's at least two groups that are randomly assigned. That's a big one. So there's some randomization, and there is some manipulation there, and that's why it's a type of experiment. The advantages here, especially with randomized clinical trials, these RCTs, are considered gold standards in evidence-based medicine and in public health. The reason it is a gold standard because everyone has an equal chance of being in the experimental or control group, and statistically that helps us understand a little bit more around causation. So what did the manipulation influence an outcome? And this is because you're manipulating that purposefully. So it really does provide evidence on the outcome. Usually you want to make sure you are selecting and monitoring the participants very well in randomized clinical trials. Another ethical reason is just to make sure that you're not harming participants But definitely to the second to last point, there's careful selection and monitoring. And another advantage is that it does provide effect sizes that you can measure and look at the strength of the association. So what is the statistical value, but also what is that strength? How much did that type of manipulation influence the outcome that you are studying? And so speaking of, the strength of the association, when we think about statistical association between two different variables, and again, that could be a study factor and a health outcome. So when we think about intervention research, that factor could be whether or not they received the intervention and whether or not that related to a health outcome like overweight or obesity. So sometimes it's different when we think about behavior research. The medical examples, you've probably seen in undergrad or those examples are just more readily available. But once we get into our field and health behavior, it looks a little bit different. But statistical association is understanding the relationship between two variables, and it's how they are related that would be expected by chance. And so usually we look at the p-value, and a standard is a p-value of 0.05. How you interpret that is that after doing all those statistics, there is less than a 5% chance, or sometimes we do equal to, so a 5% chance or less that this relationship happened by chance. Just because there's always a chance that two things are kind of randomly related. But on the flip side, it means that we are 95% sure that this was not by chance and that there is an actual association between two variables. And again, it could be that the variable is those who receive the intervention were less likely to have a particular health outcome, and if the statistics around that are 0.05 or less, then we're 95% sure that it is because of that manipulation or because of that other variable that this happened. So again, there's always chance. The standard in most cases is 0.05. In some other disciplines, especially if we're looking at other psychological variables or something that might be a new relationship that we're trying to understand, sometimes people will set the standard at 0.1. And that just means there's maybe a 10% chance that it's random, that this relationship is just that by chance. But on the flip side, there's a 90% chance, or not chance, but 90% sure that it is not by chance. And so you look at that statistically. But when we think about statistical associations, we have to rule out, did this relationship happen because there was bias? Is there something that was confounding the relationship? So we want to make sure that it was a true relationship between those variables. And again, the standards we use typically determine using a p-value. Typical standards are 0.05. Some areas in research or other disciplines might use 0.1, but again, we use 0.05. And you always want to make sure that there is no bias or confounding to rule those out as not being included into why that relationship is occurring. For example, a health condition. Selection bias happens when participants in the study are included in a way that's different from those who are not included. A really classic example is posting flyers to participate in a study. The people who end up calling and saying, I'm interested in this study and I want to be a part of it, are systematically different than those who are not interested. So there's some motivation, there's some interest. They're very different than those who do not apply. So that would be an example of some type of selection bias. They're kind of self-selecting into these studies. Again, there might be some type of motivation or some other factor, but that's selection. Information bias is a type of bias that can happen if the interviewer or the person who's doing the measurement knows the identity of either cases and controls or those who are in the experimental or control groups, if we're talking about randomized clinical trials. And the reason for that is if someone is behaving in a way that's impartial, so you know that this is the experimental group, and maybe you're like, wow, so you really did great, losing weight or influencing them in some way. Maybe the way that you are asking questions or reading the measurements is kind of leaning towards, something that is more favorable. That's information bias. It happens if the interviewer or the person doing the measurement knows the identity, and that in some way affects their behavior, the way they observe, the way they measure. Recall bias is, when you're asked to recall some type of information. So here it says recall bias, which may be due to better systematic recall on part of the cases than controls who are healthy. So recall bias just in general is oftentimes when you, even just thinking about what did you eat the last week, there's some type of, it's very difficult to recall information. And when you think about recall bias, it is that there particularly can be a difference in those who are healthy or unhealthy. So your experiences shape the things that you remember, and that can affect the type of recall you do when thinking about certain health questions or measures. So it's definitely, when you ask people to recall information, that's definitely a bias. Now, confounding variables is often referred to as like a third factor or extraneous variable. It's something that is related or kind of confounds the relationship between a study factor and the outcome. So the example that they have here is that there are examples of studies that looked at the association of coffee drinking with the development of coronary heart disease, but later it was found that it really wasn't about coffee drinking, it was actually more about smoking. So smoking and drinking coffee are related. So when you looked at the relationship without smoking, like, oh, maybe coffee, is related to, it is related, but maybe it's does coffee influence coronary heart disease? And without taking into consideration smoking, you might say, yes, that's the answer, that's the association. But in reality, smoking was a confounding variable. It was actually smoking that was related. Another classic example is ice cream and murder rates. So ice cream sales is positively correlated with murder rates. So the more you sell ice cream, just thinking about like a neighborhood or something, the more that an area sells ice cream, the higher the rate of murder, the more murders occur. Now there's a couple explanations. Maybe, ice cream causes people to want to kill someone, so ice cream causes murder, or maybe murder causes, somehow influences the need for ice cream. Now, neither of those makes sense. There's a third factor involved, and that could be weather. So as the weather gets more hot, more people are out and about, more people are interacting, and again, the weather is related to ice cream sales, but the weather is also related to people being more social, and that influences the murder rate. When it's cold out, people are often secluded and obviously not buying ice cream. So weather would be the confounding variable in that relationship. So statistically, if you were to look at ice cream sales and murder rates, they are positively correlated, they are associated. But in fact, it is weather, a third variable, that explains that relationship, and that's confounding variable. So that's always an easy way to. To your textbook, there are a lot of criteria for causation. The three that I'm going to highlight, and the way that I learned a lot about causation, and a really easy way to kind of think about it, is using these three conditions. Covariance. So again, they have to be related or associated with another. So for, let's go again with that ice cream and murder example. Ice cream sales and murder rates are related, so it meets that. The second condition is there must be a time precedence of the cause. So the cause has to precede the effect in time. I guess it could be, it depends on the delay of, how people interact. I don't know, maybe ice cream and murder rates, maybe there could be a time precedent there. Maybe ice cream rates spike first. And then because people are outside eating ice cream and interacting, they're more likely to get in conflict. There's more likely to be an incident where someone is killed or murdered. So maybe there's a time precedent there. But the third condition, that there's no plausible alternative, obviously that does not meet the condition. So we know that ice cream does not cause murder. But these are three conditions that you can use for any type of relationship and in understanding causation. So are they related? Is it preceded in time? So does the cause actually happen before the effect that you're thinking about? And the third one is that there's no plausible alternative explanation, which includes some type of bias, which includes other types of confounding variables. So there's no positive alternative explanation. So those are three conditions. Thinking about time precedence. And this, I see this a lot when people write about or talk about studies that they have read. So we talked earlier about following people, time forward. So you have maybe measuring or watching someone at the beginning of time or baseline, and maybe following up with them. In that sense, you may be able to have that time precedence. But if you are doing a one-shot study, so let's say I pass out a whole bunch of questionnaires to the whole entire campus, and I ask a whole bunch of questions and I get a lot of information. Because I only passed out the questionnaire once, and this is a cross-sectional study design, there's no way that I could do anything statistically to assume that there's some type of cause and effect. It's only when you have the type of designs that have you looking at time, whether it's retrospective or perspective, but in a way that you can see that the cause actually came before the effect. So again, as you're reading studies and as you're thinking about how to talk about, did this cause something, or was it just an association or some type of correlation? Really think about the study design. If it happened once, even if it was, I did a study and I asked people, do you exercise and what is their weight? You can maybe assume, well, whether or not they exercise has a lot to do with their weight. But in that one study, and we already know this to be true, but in that one study, you cannot infer causation because I didn't do a design where I could see, okay, those who are exercising and not exercising, did they end up becoming overweight or obese? So really, time is really important. So when you catch yourself saying, I believe this caused this, really look at the design of the study and what you're talking about. It may simply be an association, a correlation of some type. So really think about that. So again, if it's one-time study and it's cross-sectional, you cannot actually see if there's a time precedence. But if you're looking across time, either forward or backward, that sets it up nicely that you can understand causation even more. But again, here are the three conditions. Covariation is cause and effect. Are they related? Are they associated? Is there time precedence? And the third one is that there's no plausible alternative. And that is the last of these slides. So again, it was just kind of a summary to give you some of my thoughts and perspective. I'm a little bit informal, but just make sure to read the textbook and to go over some of the examples there. And I'll be posting these slides. And that's it. I hope you guys have a great weekend, and I will see you on Monday.